bien.
Oh, thank you again, Jim. So this is very interesting for sure. I mean, talking about sex is a topic that we can discuss for hours and hours.
Of
And
course.
to us, I mean, sometimes people hear about this idea of hormones and taking hormones for the pill control for pregnancy and how testosterone might be low or too high in people. And I would like you to explain us in your words, what can you tell about these molecules that affect how the sex functions in our body?
Sure. So hormones, I always like to say that hormones sort of set the stage. They create the stage, but that your experience creates the play that appears on that stage. Hormones set a stage by essentially activating excitatory regions of the brain for sex and deactivating inhibitory regions for
Sorry,
sex.
so you're saying that we have in our brain certain pathways that make us more excited about sex and some other pathways that make us to reduce sexual excitement and motivation?
That's right. So we have pathways that are neurochemical. They're defined, like we were talking about dopamine before. That's one of the excitatory systems in the brain. It's there for sex, but it's there for everything else too. There are some systems in a part of the brain called the hypothalamus that are very specific to sex, and they end up affecting that dopamine attentional system to make it focus attention on sex-related cues rather than, say, food-related cues or water-related cues or whatever it might be. Yeah. When you do that, when you focus attention, it also means that you defocus or inhibit attention on everything else. So you become very kind of unidirected in your attention. And it was really the physiologist Pavlov who showed that that's true, right? And Hubel and Wiesel, when they won the Nobel for understanding how the visual system works, they also showed that that was true. That when you focus attention on particular visual cues, you're inhibiting attention to everything else. Like when you're looking at the color red, you're inhibiting your attention to all the other colors. And that's done at the level of your cortex, right? But your conscious awareness of it is not of just the color red, it's of all the colors that are there, but you're focusing your attention on red. And we do the same thing with sex. We do the same thing with food. When you're really hungry, something sexual might get in the way. But you may say, you know what, I'm too hungry to have sex. So I'm going to inhibit the sex out and go after the food. Or you might say, you know what, I can eat tomorrow.
Right.
The sex is probably going to be too good. So you focus your attention on the sex and not on the food, even though you're hungry. So your attentional mechanism is kind of wired that way in terms of almost a hierarchy. Some things you like more than others. And those are the things that are going to gather your attention. But because you have inhibitory systems in the brain, and again, I mentioned some of them before, like serotonin and the opioids, when they come online, they produce inhibition. But that inhibition you experience as intense pleasure and something called satiety. So when you've eaten a big meal and somebody comes out and says, oh, do you want more of this? You're like, no, I can't eat another bite. I'm so full. And it's not just because your stomach is distended. It's because serotonin has come online to produce a feeling of satiety. So when that happens, you're fine and you feel good. Okay. So those are inhibitory systems, and your brain has both, and they follow a pattern where you start with excitation, things like arousal and desire. And when things start getting sexual and you start having intercourse and there's genital stimulation, and this drives you on and on up to the high point at orgasm. And then you go refractory. Why? Because the inhibitory systems are actually inhibiting the excitatory systems.
This is interesting. as once you explained to me, some urologists actually recommend increasing your serotonin levels in order to retard premature ejaculation. So that is like taking advantage of inhibitory systems to reduce excitatory systems and no.
Well, to reduce excitatory systems that are too excited.
Exactly.
Right?
So you think how important it is to understand that when someone is actually experiencing depression and is taking antidepressants and is experiencing all these side effects, all these negative side effects because they're no longer experiencing good libido, it's important to understand how these neurotransmitters or the molecules that we know in the brain are actually inducing effects in inhibitory systems that might actually be having an effect. So
that's true.
What is your point of view? What is your recommendation for people that actually have to take these medications prescribed by the doctor, but at the same time are having these side effects? What is the way to go?
Well, people need to understand, the doctors need to understand that those side effects are real and there are ways to deal with them. So for example, when you're on a drug like fluoxetine or paroxetine, these are serotonin reuptake inhibitors called SSRIs. And they're quite specific to serotonin, relatively specific, I should say. And what they're doing is depressing, because the serotonin levels are so high, they're depressing dopamine and noradrenaline. Now, there's a drug called bupropion, which is, a DNRI, so it's a dopamine and norepinephrine reuptake inhibitor. So when you give bupropion, in some people that is beautiful for treating their depression, and they don't get any sexual side effects at all. For other people, it doesn't work very well, whereas a serotonin reuptake blocker works better. Now, what could you do? Well, you can give bupropion at a reduced dose and reduce the dose of the serotonin reuptake blocker. So now what you're doing is you're balancing out these excitatory and inhibitory influences. And if you think about it, kind of like, like a teeter-totter when you're a kid and one person's on one side, the other kid's on the other, and you kind of go up and down, up and down, up and down. You can think of that as being, excitation on one side and inhibition on the other. And where you want to be is not where you're weighed down by inhibition. You also don't want to be weighed down by excitation, because that's going to make you like a premature ejaculator. You want to be in the middle where you can kind of go down if you need it or up if you need it, right? You don't want to be locked in. So you want that to be labile, meaning that it's able to go down and up. It's not going to get stuck, right? Where people have sexual problems is when things get stuck. And they can get stuck, to get back to the hormone issue, they can get stuck because the hormone levels are low. Now, when does that happen? That can happen in men with testicular cancer, with prostate cancer. It can happen with infections. It can happen with smoking and with diabetes. Testosterone levels go down. And when they go down and reach a certain threshold, you just don't feel it anymore. What about women? Well, we know that all female mammals, in fact, maybe all female vertebrates, have an ovarian cycle. So there's a point at which they ovulate. And when they ovulate is also the point at which behaviorally they show that they have the most libido, they have the most desire, right? We would say, well, they're horniest when that happens, right? And they show different behaviors. They react differently to males. They start to solicit the males and they run away, or they do all the things they do to make the males chase them and court them and give them gifts or whatever it is, right? Depending on the species. Well, why does that happen? That happens again because of testosterone. When you ovulate, you give a burst of testosterone from your ovaries. Okay. Now, prior to that, estradiol has gone up, estrogens have gone up. Just
Hormones are these substances produced by our gonads that play with the threshold, how excited or inhibited your brain is.
that's correct.
But I have a question. There is a saying there, the story seems to tell that eunuchs who were castrated men taking care of princesses were not meant to trust, because apparently if they had sexual experience before being castrated, they remained, they had this the possibility to continue having sexual intercourse and getting excited even though they didn't have hormones.
Right.
What can you tell us about that?
Well,
is it myth or is it kind of real?
no, I think it's real. The problem is, were they, think about this, like if you were a gay male, think about it. Were you the top or were you the bottom? Now, the eunuchs were always able to be bottoms in that people could have anal sex with them. Okay. So having sex wasn't the real question. Did they enjoy it and want it? That was the real question. And did they enjoy it because they had orgasms? No, they never did. Could they still get erections? Yes, if they had sexual experience prior to becoming eunuchs, they could still maintain their erection. And why is that? So not everyone who loses their hormones loses their sexual behavior. About a third of people that lose their hormones don't lose their sexual behavior. So what do we say about that? What's happened? Well, we know that experience with pleasure, which sensitizes those excitatory systems, in some people sensitizes them so much that the experience alone and the expectancy activates those systems without the hormones present, right? And this is something that we can see even in, men who are pedophiles, for example. People give them a drug that will reduce their testosterone levels, thinking, well, okay, if we do that, then they're not going to have any, pedophilic interest anymore because they're not going to have any sexual interest anymore. But it turns out in about a third of pedophiles, they still maintain their ability to get erections, right? And in about 2/3 of pedophiles, they still maintain their interest in having sex with kids, even if they can't get an erection. So the testosterone synthesis and inhibition doesn't work. It's never worked. But people think, well, it should work. If we just do it right, it will work. But it doesn't. And that's because the hormones and experience end up doing kind of the same thing by sensitizing those excitatory systems.
Right. So men and women are different in many ways. And my next question would be, how different are the brain differences, or how the brain differences contribute to the different expressions in sexual behavior, sexual expectation, sexual desire in men and women? There is some people who actually believe that there is neurosexism. The scientists are talking about that minimal differences in size in brain nuclei are too tiny to be considered as important for sex differences in the brain. However, you as an expert have been exploring these brain differences not only in size and in organization, but you know that there are different molecules in those tiny regions of the brain that make big differences. And the patterns of release are actually what matter, not necessarily the macro differences. So what can we tell people who believe that there is neurosexism and men and women are exactly the same?
Well, I mean, I think to some extent, it's not that men and women are exactly the same. It's that each individual is a little bit different from another individual. And there's work that's been done looking at, functional patterns, not just size of different brain regions or size of, say, a particular, bed of neurotransmitter containing neurons in a region, like oxytocin or vasopressin. But they look at the whole brain and they look at it from a functional standpoint. So we not only have these differences in size, many of those differences in size, by the way, favor females,
Right.
even though their brains are about a tenth smaller than males, right? So we can look at that and say, well, females have smaller brains, therefore what? They're dumber? No. Therefore they are more constrained? No. In fact, from physics, we learn that if you have the same number of neurons in a smaller space, the same number of things in a smaller space, defines efficiency.
Right.
So women's brains must be more efficient than the male brain because it's bigger and has the same number of neurons, but it's within. But really, for efficiency purposes, it depends on what you're looking at. And that depends on the individual and the individual's experience with whatever the individual is doing. Okay? We find sex differences in these regions. Some of them favor men. Some of them favor women. More of them favor women than men. So, for example, the corpus callosum that connects the both hemispheres of the brain, yeah? That's 16% bigger in women than it is in men, even though their brains are smaller. So what does that mean? Well, here's a good example, and it's not a sexual example. I'll get to the sex in a second. Right-handed men have language largely on the left hemisphere of their brains, okay? And if you have an accident and you hit the left side of your brain on the temporal lobe, where those language centers are, men get aphasia. That is, they get the inability either to make speech that makes sense or to perceive of what people are saying to them that makes sense, right? So if you have a production aphasia, you may say, I want to go to the bathroom, but it comes out, dog on earth eat trees. And somebody's like, what? And you're like, yeah, dog on earth eat trees. And you're like, I don't understand what you're saying. And the person's really saying, I want to go to the bathroom, but the words are all jumbled. Okay. Likewise with expression aphasia. Yeah. Somebody says, do you know where the bathroom is? And the person says, I know what each of those words mean, but I don't know what you're asking me. Okay. So that's with a little bit of damage in the left hemisphere. When women get that damage, nothing happens. When women get damage on the right hemisphere and the left hemisphere, then they have the same kind of aphasia that men do. But their language is more distributed on both sides, and people suspect that that's true because the corpus callosum is bigger.
Right.
Okay? Now that's a sex difference between males and females. The same sex difference exists in terms of the production of ultrasonic vocalizations in female rats relative to male rats. So it's kind of a similar kind of distribution. And sure enough, female rats have a bigger corpus callosum than do male rats. That's been preserved in evolution. Okay. So we can look at that and say why, but really the answer is that the functionality of the brain is a mix of male-centered and female-centered patterns. And everybody has both, but they have it differently, right? So you have it one way, I have it another way. And I could look and say, oh, well, if somebody could calculate the pattern, which people have done, by the way, they could look at my brain and say, oh, you know what? Your brain is 60% female and 40% male. That doesn't make me any less male. Right? And they could look at your brain and say, well, your brain is like, 51% male and 49% female. That doesn't make you any more female than me. And it doesn't make our brains, it simply means that we have tendencies that we might be able to experience and express. But everybody's different. And that's the key.
this takes me to a different next question, Jim. In the last 25 years that we know each other, we've been exploring together when I was in your lab, and thereafter, we've been exploring the interaction between nature and nurture somehow. How biology sets some organization of the brain, but then learning and environment changes plasticity in the brain and makes other things important that weren't important before. Salience in certain stimuli that were not important before. So regarding this, so far we understand that we all, humans and animals, are a mixture of nature and nurture always. But people in some countries, Mexico, for example, probably Latin America, and probably Southern United States especially, might be still thinking that people is born the way it is and should stay the way it is forever, and anything that doesn't correspond to the reproductive purposes of sex is abnormal and don't allow space for the environment and learning to take place in all these differences that you are talking about that make us unique. So what is your opinion about this interaction of biology and environment, thinking about learning, in the expression of sexual patterns, sexual orientation, sexual gender, and pair bonding? Mm-hmm. How do you integrate nature and nurture in all these four processes?
Sure.
Sex.
So, okay. So we have four different things that we want to integrate here. Let's integrate the first one. And the first one has to do with sexual behavior. So we've already talked a little bit about that. We know that hormones activate systems, and we know that your experience activates the same systems. And the experience can, in many ways, kind of take over from the hormones, especially if the hormone levels go down. And why? Because they're integrated. The hormones can sensitize, and experience can sensitize. Yeah? And, we see that as something that we would call automation. Okay? So dealing with, take the example of driving a car. The first time you try, you have, 3 legs and 4 arms, and you have no idea what to do. But a year later, you drive without even thinking, right? Well, sexual behavior gets automated like that too, right? We know from work that, that you and I were part of going back even 20 years ago, that regions of the brain like the cerebellum that are very important for motor adjustment and motor movements, right? As male rats, for example, are learning to have sex, activity of the cerebellum is greatly increased. Now, even though it's activity of an inhibitory neurotransmitter system, it's not inhibitory for sex. What it is inhibitory for doing behaviors that have nothing to do with sex. So now you're learning to focus your attention, like you do when you learn to drive a car or playing a musical instrument. Yeah, you focus your attention, and you focus then your motor output along with the focused attention. So now behavior gets automated by experience. And that automation protects the behavior from things that could disrupt it. So you may recall studies that were done in our lab where we tried to use lidocaine on the penis to get male rats to stop having sex. And the ones that had 10 sexual experiences never stopped having sex, even though they're not getting any sensory feedback from their penis. The ones that had 5, they could mount and intromit, but they had problems ejaculating. The ones that had only 1 sexual experience or no sexual experiences would try to mount, and then they, when it didn't work, they'd go off in the corner of the chamber and act like they were sulking, like they were very upset. Okay? So what defines that difference? Automation, experience, nurture. The nature sets it up, but the nurture creates a habit. Okay? Right. Now let's use that as a basis for understanding these other aspects that you mentioned. So let's take something like sexual orientation. Okay, gay or straight. Or neither. Okay. Now, I'm not talking about gender at this point, I'm talking about orientation. What are you attracted to? Well, some of that is innate. And we would say, well, the more innate it is, the more reproductively relevant it should be. But it doesn't turn out to be the case, right? The innateness starts very early, before you have any idea about the way the world works at all. And it begins to grow in you as you grow up, right? So you may find yourself when you're 7 years old being attracted to boys and perhaps even getting erections around boys. You don't know what it means yet. You're not saying, oh my God, I'm getting an erection. I'm 7 years old. I must be gay. No, you don't say that at all. It's just, you kind of like it. And maybe you might even experience some sex play with another 7-year-old where you guys are like, masturbating each other, showing each other your penises. And that's perfectly normal behavior. Kids do that with each other. It doesn't mean they're gay. It doesn't mean they're straight. You're not going to know until the hormones turn on and start to make the areas of your brain that are those excitatory regions for sexual behavior turn on. Because before that, they're not turned on yet.
Sorry, a
Yeah,
parenthesis then. Could you say then that is in puberty the time where more clarity regarding sexual orientation might occur?
that's exactly right. And so, not gender orientation, we're talking about sexual orientation. I am attracted to people of my same sex. I'm attracted to people of the opposite sex, right? And that goes hand in hand with other things that you're attracted to. I'm attracted to blonde people. I'm attracted to brunette people. I'm attracted to people who look like me or who have the same racial characteristics that I have, right? Or I'm attracted to people that are more exotic, who have different racial characteristics, different whatever it might be, right? So you start to get a composite together of something that you like, and it might still be fuzzy in your head. Then you also have random chance. So what do you look at when you masturbate? Do you look at males? Do you look at females? Do you look at females with a certain body type? Do you look at males with a certain body type? Do you look at, so all of this begins to play a role, and the masturbation begins to help crystallize it in your brain because of the rewarding effects. They sensitize then these dopamine systems. So now, among an array of people, all of whom maybe you could have great sex with, we call it a gestalt in psychology. You're going to start to pick out in your environment from the background, things will pop into the foreground. And you're going to look at them preferentially and say, oh my God, that person is really attractive to me. I want to have sex with that person. Then you got to learn some social skills. And then eventually, when you start to become sexually active with another person, this becomes the pattern of choice for you. It doesn't mean that you can't have an experience later on that will change that, but it's just much harder to change it. And of course, there's a sex difference in that. Women are more fluid with regard to that than men. And that may be a function of testosterone. Our testosterone, which is at a very high level and sustained level, and not fluctuating like women's do around the time of ovulation. So it may be the case that testosterone locks us into patterns, and we see this with erections. Bring men into the lab, gay men will show erections to gay porn, heterosexual men will show erections to heterosexual porn, and they don't show erections to each other's type of porn, right? Whereas you bring women into the lab, and they show clitoral erections and vaginal blood flow that's producing the clitoral erection, they show that to all different types of porn. And some of them may say, well, I don't consider myself bisexual, but I'm not a Kinsey zero either. Okay. I'm like maybe a 1.5 or 2 because I've had some sexual experience with other women. Now, what is that? Men generally don't say that. Some men do. And so what pattern do they show? Well, they show a pattern that would be bisexual, right? That they get erections to gay porn, they get erections to straight porn, right? So sexual orientation then is something that grows almost the way you would build a building from the foundation up. And once that foundation is laid, then the building gets built. And once the building is built and all the damn furniture is in it, puberty hits.
Right.
And you can go in and occupy this building as a gay man, as a straight man, as an asexual person, as a whatever. Okay? Now, what about gender? And this is where we have a big problem. So here's where gender becomes a problem because people conflate it with sex. So they think sex is male, female. Gender, which can be masculine or feminine, somehow is the same thing. Well, gender is a social construct. Okay? Boys will be boys. Well, what does that mean in China compared to Mexico? What does that mean in the Inuit in the northern part of Canada relative to, I don't know, the in the sense that it's not innate.
Yeah.
It's sociocultural in the sense that it's imposed by the culture on you.
I have a question about that.
But wait a minute, Henry. Here's the clincher. The brain is in between biological determinism and social constructionism. And the thing about the brain is that it is a plastic organ. It's a use it or lose it function. Okay? And brain plasticity means that when you learn something, you learn it. There's no reason why everybody on this planet shouldn't be drinking tequila. But some people drink tequila and they get sick the first time they drink it. So they don't want to ever smell tequila again. They have a taste aversion. And that is very difficult to change in them because they'll drink another alcohol, but they won't ever drink tequila. So the plasticity of the brain means that it is nurture. Okay, nature kind of sets everything up, but like hormones do, hormones are part of that nature. They create the stage, but the experience creates the play that's on that stage. Yeah?
Yeah. Regarding the tequila, I call it the John Garcia's effect.
Right.
And regarding the positive rewarding effect, I call it the Jim Pfaus effect. You know, all the studies that you have performed. So regarding gender as a social construct, my first question would be, if it is a social construct, why then are benefit from hormone replacement? Why would they want to have hormone replacement if this is a social construct?
Well, because your feeling of gender, just like the taste aversion, right? Or like the taste preference, your feeling of yourself as masculine or feminine feels like it's hardwired, right? I've always felt this way, right? Now, when kids have gender dysphoria and they feel like they're the other sex, they adopt a gender attitude that makes them the other sex.
Right.
And they feel that they're the other sex. Now, do we have evidence of this in the brain? Well, there's some old evidence, but the evidence is not very good and not replicable, right? It's not that gender dysphoric kids have the opposite sexed brain.
Right.
They have a feeling that nobody understands yet that they are the other sex.
Right.
But the other sex gets conflated with the other gender.
Right.
So if I grew up feeling that I was a girl, I don't want any boy toys. I want girl toys. I want to dress like a girl. I want to look like a girl. And eventually my brain, because the plasticity is there to begin with, now it coalesces, it crystallizes into my own self-concept of
Right.
looking at myself in the mirror and saying, I'm a girl. I look like a girl. I act like a girl. I am a girl. That is me. And that becomes a self-definition.
Right.
And we can either respond to that by saying, well, you're wrong, and we're gonna like beat it out of you. Or you can respond to them by saying, okay, that's what you are. How far do you want to take it?
Right.
So when they be, yeah, so
definitely we need a complete podcast to talk about gender roles and gender identity, because
absolutely,
it's such an important topic so far currently in the society. I have this small idea about that sometimes it's safer to consider gender identity as a social construct than as a biological mechanism, because considering biologically might imply government to take care of people who are actually suffering from gender dysphoria. And if it's biological, they might have to take action into helping them because it's part of their innate nature, right? Rather than a social construct.
Well, and that was an argument that was used, like, it was an argument that was quite controversial in the 1990s about homosexuality, when people found, for example, brain regions that looked more female-like in male homosexuals. They could say, aha, see? That's what did it. It's innate. And as long as it's innate, it's like being a black person. They can't stop themselves from being black, so we should treat them equally. Right? But other people said, aha, so once you discover the brain area that produces homosexuality, you're going to go in and try to get rid of it, try to zap it out, so that you'll now have no more homosexuals. Well, obviously there's not one brain area that produces homosexuality, just like there's not one brain area that produces, your feelings of gender, of being male or female, right? It's a functional set of brain regions that work together that give you that impression, right?
More like a track from the very front of your brain to the very back of your occipital cortex that gives you identity and the self-identity, right?
Exactly. And again, here's where it is biological. It's just not predetermined. Yeah.